All right, I don't need to shout anymore. So welcome to this session. Yeah, looks very interesting about cutting edge software. We're going to start with Eduard from Tartu in Estonia. Eduard is a geospatial specialist with this company called NextGIS and is going to introduce this interesting topic on version control with geospatial data. Eduard, the floor is yours.
Thank you very much. I want to use this microphone. Can you hear me backwards? Everything's fine? It's better to use microphone? Okay. So I will go this way. Strange. Two microphones at once. So my name is Eduard. I'm leading Serbian office of NextGIS. So I'm not from far away, from Novi Sad. I like Mostar very much, and thank you for having me here today. I will share something about our platform and our approach to build multi-user mapping environment based on QGIS and NextGIS Web, our framework. So we are here for almost 15 years. We are geospatial software developers since 2011. Now we have financial center in Estonia and development center in Serbia, from where I am now. We are not very big company. We have around 40 people right now, and we are largely open source company, publishing almost everything we do to open source from the beginning, from the very beginning. So we may already know each other. Actually, we are core committers and one of the largest QGIS plugins developers in the world. Maybe you already use our plugins. For example, the most popular plugin worldwide, Quick Map Services, is ours, having almost 9 million downloads. We are community events makers, translation coordinators, and we love QGIS. QGIS is our home. We also commit to GDAL, maintaining a couple of formats inside of it, and we are long-term supporters for OpenStreetMap. So I feel myself in right place right now, being on FOSS4GE. We have NextGIS Web as a core of our platform. It's open source WebJS focused on data management. So NextGIS Web is about taking different data sets, data sources, vector layers, raster layers, OGC services, attachments, files related to features, and all the stuff with JS connections, take it all together, integrate in one place in your WebJS, and then publish this data again under your control as web maps, other IGC future IGC services, tile services, etc. So there is a GitHub, and you can make yourself familiar with it. NextGIS Web is a highly data-oriented WebJS, and as a data administrator, you work with system like tree of resources. So what you have is like file system where you can create, upload, and publish resources. We call resource everything, like layer is a resource, map is a resource, style is a resource, etc. And you simply like working with such layer tree, and a map, published map, is just another resource in your tree. That this approach allows us to build advanced rule-based permission management on the resource level. So one of the key features of our platform is its ability to set permissions on the resource level. So you can flexibly set up permissions for each layer, each map, etc. And there are built-in web maps. So you have web map as a resource. You can create as many as you want and connect uploaded data to these web maps. And so this is what NextGIS is. Of course, we wanted from the scratch to build some integration with desktop, and obviously QGIS as part of our ecosystem. And for good 10 years, we had some standard publishing integration with a simple idea: let's publish QGIS projects to web. So we had this thing button in QGIS, you push it and you got this project published as a web app. To do it, we used a couple of things. First thing is using QGIS as web map renderer. So for this purpose, we developed a component named QGIS headless to use it as a renderer on the server side. So everything you can see web map, just because they use the same renderer. So it's also open source, of course. And we built NextGIS Connect plugin to manage this interaction. So you can connect to your web.js and publish your QGIS project to web. That was. I'm sorry. Two is too much for me. I only can handle one. Yeah, sorry. It's tricky situation. Okay, I hope everything is fine. So we used this approach. We have been using this approach for 10 years, but then we felt that it was not enough because actually publish QGIS project to web is not a really big problem now. There are a lot of good solutions to publish your QGIS project to web map from QGIS. A lot of nice icons of beautiful services I enjoy. So it's not a problem anymore. And we decided to go deeper with the thought that we want not just publish data, we want to create integrated collaborative workspace in QGIS, Web QGIS, like altogether. So the first step is what has been already done 15 years ago, is simply publishing your QGIS projects to web. Okay, simple, it works. Okay. Next step is to provide the opposite direction, yes, to be able to connect to these web maps from QGIS and grab them as a QGIS projects. So you can take 100 people and they all can grab this QGIS project from NextGIS Web and continue to work with it as with QGIS projects. Then enrich this process with some native collaborative data editing. So from QGIS instances and from built-in web maps. So people could connect to this web map and start editing the data right on server, but from their QGIS instances together with other people from other QGIS instances and together with people who use web maps built into NextGIS Web to edit the same data. And then over this, on the top of these mechanisms to add some enterprise level features. I'm not sure I can call them enterprise level, but anyway, like real-time conflict resolving, if we like edit the same features, feature versioning and tracking to know what happened, etc., and offline editing with syncing when online, without limitations of like ODC services, etc. So we did it in some way, and how it works now, you have QGIS project, you simply publish it to NextGIS Web. You can go to NextGIS Web graphical interface and set up permissions, users, it's all the stuff, and then people just connect to it and start using this project from web browsers and from QGIS instances without database administration, trigger setup, any coding. So the main idea was to build some kind of out-of-the-box solution, so you can simply publish project and then 100 people start editing it from their QGIS instances or web maps, with whatever they prefer. So minutes from local QGIS projects to collaborative work with team of any size. That is an idea. Now you'll see some screenshot-powered demo because we were aware not to provide real life demos. So let me go this way. So this is QGIS project. It's City of Monster with a lot of layers, richly styled with like geometry generators, custom SVG icons, and all the stuff QGIS gives you, point clustering, etc., etc. You have plugin named NextGIS Connect. When you run it, you can see the panel on the right side. And in this panel, you can set up connection to one or many NextGIS Web instances, servers. So you set up this connection and see the layer tree and maps tree in this panel. After that, you can just push upload all button, and your layers, maps, service connections, PostGIS databases connections, all other stuff you use in your QGIS projects um, is downloading to WebJS, and you can see in like resource tree of WebJS all your data, maps, base maps, and stuff like that. After that, you can open this project as a web map with dedicated address, and this web map is looking exactly as your QGIS project, thanks to QGIS headless renderer. But it's not like rocket science, and there are a lot of publishers doing same thing for now. So what next? Next is that another person and another QGIS instance in another country or continent could connect to the same WebJS from NextGIS Connect and find the web map and press Add to QGIS button. And the full project is restored on his computer. The styles, the project tree, everything is fully restored. And you can see that layers, they have some unusual icon on the right of them. And not standard QGIS thing is synchronization status for each layer. So we, after connecting to NextGIS Web project, web map, we establish some kind of bridge between our local project and WebJS. And you can track the status of synchronization for each layer. So you can click and see that layer is synchronized, or if you will like modify the layer, you will see that one change is not synchronized. You can like force synchronization or wait until it will be automatically done, etc. So this mechanism is built on the top of standard QGIS stuff. After that, we can go with the following. You can connect to this map, to these data sets from various clients. On the screenshot, we have built-in web app with editing possibilities and a couple of QGIS clients connected to the same data set, to the same web map. And you start to draw things, edit features, etc. And all participants immediately see the results of other people edits in their QGIS, web maps, or wherever they work in with these mechanisms. So this is how it works. And if occasionally two people or more people edited the same feature but in other different ways, so one person drawn this kind of polygon, this another person drawn another kind of polygon, there is a conflict, QGIS sees it, and dialog, conflict resolution dialog appears saying, okay, there is two different versions of the same feature on local QGIS and on the server. So you have, as an operator, data editor, you have to decide which version is correct, or maybe combine some like united version, taking attributes from one version and geometry from other version. So yes, that is how it works. Key underlying technology to provide this to be possible is feature versioning, because without tracking what happens with all the features on the server side, it's impossible to resolve conflicts and do all this stuff. So this feature versioning implemented on NextGIS website helps us to know all transactions, commits with sources, who did this, time when it was done, and content, what was exactly edited. So we can always perform synchronization, detect conflicts, and perform offline synchronization when we have an internet connection, etc. A couple of words. I have another 5 minutes, so I will talk a little bit about what's inside. So we use PostGIS as a way to store vector layer features. NextGIS Web. So whatever you uploaded to NextGIS Web, it's sent as table in internal optimized indexed storage. And there are several approaches, temporal standard approaches for PostgreSQL to handle like versioning stuff, etc. Usual approach is to use temporal tables. I think you could be familiar with this temporal feature tables approach, but we found it kind problematic because it's hard to process deleted records. There are many side effects with timestamps and a lot of activities required with blocking the tables. So we made an approach, but fastly realized that it's not the way to go. So we came up and realized our own approach to version the features on the server side. So I will quickly run through the table structure. So when you have only data itself, your versioning is disabled, no versioning. You have table for data. Yes, we have two features in like this simple layer. We have several additional tables storing attachments like file, PDFs, photos, etc., and descriptions for these features. But everything is quite clear. Then we activate feature versioning. When we activate feature versioning for particular layer, three additional tables are being created for this layer. One table with current versions, so we can see that now we have, for each feature, we have version ID and we have operation of genesis of this feature, in this case, creation, C. We have metadata table with versions metadata, having information about who produced this version and when he did it. And we also have table for keeping history of all changes, where features would be features state would be stored after changes. So imagine that we changed one attribute of feature number one. What happened? So in current versions tab, this feature was changed to version number 2, and Genesis operation is changed to update. At the same time, the previous version of this feature is stored in history of changes. So we know that there was first version of this feature with this geometry and these attributes. And we also created new metadata record describing that this second version of layer was produced by admin in this time. It helps us to like descript everything and easily request when, by whom, and what happened. Another example, feature has been deleted, so it changed its state to new version and delete Genesis separation, new record and metadata table, new record and history of changes table. So we still keep the latest state of this feature in some special table, but in data table itself, there are no more of this feature. So these mechanisms allows us to ask and answer questions like, I want to see all changes made by user Alexander. I want to see state of this particular layer on this particular time, or I want to make a branch of layer state on particular period of time, etc. This functionality is accessible through API, so you can like go through the histories, etc. And for now, it's for us, it's the most important part is that NextGIS Connect and this QGIS integration widely uses these mechanisms to communicate with server, to resolve conflicts, to make it possible, like multi-user editings, etc. So it's all thanks to this feature versioning control system. That's all from my side. Thank you. Let's keep in touch. There are GitHub links, and we also provide SaaS and supported on-premise installations for those who don't want to deal with like just code. I'm here. We'll be happy to answer any questions. Thanks a lot, and see you.